the GEO-Academy approach, actually as an introduction, and how to integrate geospatial activities related to education for sustainable development. A brief outline of the presentation, the introductory part about the GEO-Academy project, the methods we followed and used for the past 2.5 years, actually. The project is coming to an end in 4 months, actually. A few words about the GEO-Academy results, some challenges and opportunities, but the most critical, let's say, part, we will present some geospatial concepts and tools that we think and we consider that they're enhancing education for sustainable development and transformative learning. A few snapshots, let's say screenshots from our e-module structure and the training and teaching resources, and for the closing, some key takeaways for the first presentation. So about GEO-Academy, the whole idea for this project started 5 years ago, conceptually, because we have collaborated, most of the organizations of GEO-Academy during the past 10 years. For other European projects, they were all focusing on education and geospatial technologies, actually, or geospatial concepts. The first one was GeoThink for semantic pathways to build a spatially thinking society. Viste, an amazing project for empowering spatial thinking of and for students with visual impairment. The GoSTEAM project, how to use geographic information systems and into STEM education and STEM learning. ClickPolit, GIS-related light pollution and geographic information systems and technologies. And one amazing project we didn't participate into, but the results were pretty impressive, the GIS for schools, and we're taking advantage of the GIS for school results, and of course, from all the past projects in GEO-Academy. So using this pathway, we ended up to the GEO-Academy project 3 years ago, 12 partners, 7 European countries, starting from west to east, Portugal, France, Austria and Sweden, Bulgaria, Greece and Cyprus. A huge collaboration of universities, NGOs, associations related to education and education for sustainable development, pedagogical institutes, and I think I'm not missing something, and schools, of course. The core idea of the GEO-Academy, let's say it had 2 pillars. The first one was that how we are talking about education for sustainable development and green skills and everything, and we are not incorporating the digital skills and geospatial technologies and the spatial abilities, the spatial skills. So we were thinking 3 years ago about, let's say, a unified framework. 3 years ago, of course, the Green Comp and the DigiComp, the first versions of both competence frameworks were published. So we had this, idea, how can we unify green, digital, and spatial skills? And why those skills and geospatial technologies, they are important, because geospatial technologies and geographic information systems and Earth observation and remote sensing, everything is related to different sustainable development goals. Here is just one visual of how GIS, different tools, spatial data, satellite observations, they are tailored, they are interwired to the different sustainable development goals about no poverty, zero hunger, good health and well-being, quality education, clean water, etc., etc. So we had the unified competencies idea, and we needed some superpowers, as we call it in the GEO-Academy, the geospatial technology superpowers. So we needed, and we didn't invent, but we had the idea to discretize different superpowers related to geospatial technologies. Namely, the first one, geographic information systems, cartography and thematic mapping, remote sensing and Earth observation, geospatial or map storytelling, and last but not least, STEAM, robotics, and of course, programming within education for sustainable development. So we had the superpowers, we had the unified competence framework. We tried to test different pedagogical methods and models. And our core methodology and the results actually are described within the next 5-6 slides. First of all, the competencies. We mentioned the green competence framework, the digital one, and the spatial skills. During the project, we unified those competence categories and discretized them to different knowledge and skills, not attitudes, because it was just an academy and the main purpose was to train teachers and educators across Europe. But at least we developed different levels of knowledge and skills under unified competence categories, embedding sustainability values within the context of spatial literacy, system and critical thinking for complex geospatial challenges, envisioning and acting under the lenses of spatial citizenship, and many, many more. More detailed categorization here with the subcategories of the unified competence framework. So that was, let's say, the first important milestone for the project. The second one, to link the unified competencies and the learning objectives, and of course, geospatial technologies within different, let's say, curricula structures across the countries participating in the project, actually. So we linked, let's say, those competencies and those thematic areas, those geo-concepts, as we call them, into different curricula, of course, in Austria, Greece, Cyprus, Portugal, Sweden, France, and in Bulgaria. It was like a screening analysis to identify, let's say, the degrees of freedom we have in each curriculum for each one of the participating countries. Concepts and pedagogies, super briefly, we developed for all geo-concepts, activities related to open schooling, to whole school approach, to the living labs approach, and that's why we developed the GEOBSERVE platform. You will see the GEOBSERVE platform from Gustavo. It's the second presentation today. So we try to embrace teachers, first of all, to use transdisciplinary learning, to let their students to collaborate with external societal actors during formal, non-formal, or even informal educational settings. And we developed activities for our geo labs, as we call them, the schools that they're tested, those activities that are trying to follow, these schemes of openness, of collaboration, and of those linkages between formal, non-formal, and informal education. Our training model, because as we mentioned, we are an academy, and the main goal was to train teachers. Actually, we had a training model for all series of training that I'm going to show in the next slide. The core idea of the training model developed by the Pedagogical Institute of Tyrol was to link the curriculum with the sustained learning outcomes and objectives about green, digital, and spatial topics. And that's why the model is called the Bridge Teacher Training Model. We try to follow it during our trainings. Extensive series of training events, both national and international training events in all participating countries, 3 international training activities in Greece, Austria, and Portugal, and in 3 months by now, in April, we have our closing conference, the GEO-Academy International Conference in France. Some screenshots from the training events. Here is in Greece, in Marathon. It was July 2024. Our first winter school in Vienna, in Austria, 2025, February 2025. The summer school last year in Portugal, July 2025. And we are moving forward to explain a bit more about the training and the teaching resources. So a lot of training, but training about what? About different geo-concepts, about different geospatial technologies, tools, pedagogical aspects. As we mentioned, those geo-concepts are and were, are, and will be our superpowers for the training events. 4 categories: cartography and thematic mapping, GIS and Earth sciences, Earth observation, map storytelling, and coding, robotics, and STEM education. We developed training courses, and they were uploaded on the GEOBSERVE platform. And also, we created an extensive list of geospatial tools that the teachers, both in primary and secondary education, may use in order to develop or replicate activities that we are showing during our courses. All training resources and teaching resources, they are structured on individual courses on the GEOBSERVE platform, the online portal we have in GEO-Academy, under those 5 superpowers, those 5 categories: GIS, cartography, Earth observation, map storytelling, and STEM, coding, and robotics. We will start from 2 additional modules we developed, introductory ones about the unified competence framework, so that the teachers are aware of how the training and teaching resources were developed, based on which competence areas, learning objectives, knowledge, and skills. So the introductory module or course, let's say, it's about the unified competence framework, and we are explaining the importance of the green competence, the digital competence, and the spatial citizenship concept. And we have dedicated activities and lesson plans, mainly for primary school students, or let's say warm-up activities for secondary school students, you know, to understand what the unified competence framework is all about. The content and the curriculum of the first course about the unified competence framework: introductory parts, lesson plans, introductory parts, lesson plans, and more activities, focusing on the digital competence framework, the green one, and spatial citizenship concept. And we move forward to the superpowers. First module, core module, let's say, about cartography and thematic mapping. In each one of the courses, we have, let's say, a theoretical part for teachers to get introduced to each one of the concepts. What is cartography? What is thematic mapping? Different types of thematic maps, projections, geographic information systems, coordinate systems, etc., etc. And then we have some practical exercises, and the last section, some lesson plans with the respective teacher handbooks that the teachers may use in order to integrate these activities into their teaching practices and routines. For cartography and thematic mapping, we have many different categories, let's say, of how we can take advantage of maps and cartography. We also have resources related to tactile cartography, to maps, 3D visuals for people with visual impairment, how we can produce such maps, people with noise, etc., etc. So the first superpower and the first module, cartography and thematic mapping. The second one, let's say, somehow it's slightly more difficult, GIS for Earth sciences. It's super practical, because if someone wants to use geographic information systems, we have to use, you know, platforms dedicated to data downloading, analysis, processing, and visualization. Still, we try to develop activities, to keep it simple and develop activities that can be easily integrated and implemented by teachers. We have the theoretical part about different data formats, tools, online platforms, also online platforms for teachers, for climate change, for different environmental problems, for disaster risk management, and many, many more. Practical exercises on how to create, for example, a 3D map. Here it's for India, or here at the bottom, you just see a picture, how you can create, meteorological maps. This is one for Austria, temperatures across Austria, and how the students actually can create, let's say, continuous surfaces and recreate, a meteorological, let's say, forecasting report. We also have lesson plans, living labs, as we call it, activities, and we also saved activities from previous projects as well, like the Ghost Team project or other related projects. The next superpower, Earth observation and satellites. Of course, this is something that triggers, students' interest and teachers' interests way, way more, and how we can take advantage of satellite observation for different climate-related or disaster risk-related problems. Still, the theoretical aspects of satellite observations, we have the basic courses for the teachers and some theoretical, let's say, sections, and then the core practical exercises, including real-time activities in the form of different lesson plans. Map storytelling, the ultimate hype, let's say, for schools related to geospatial technologies, and how students and teachers, of course, may create different stories, actually, for different problems, but using, different types of digital tools, digital maps, audiovisual content, images, maps, everything. And that is quite interesting. We have one partner in the GEO-Academy consortium. They are quite experienced in map storytelling. They have organized national competitions here in Greece, and also there will be one competition in Cyprus. And of course, we had the pan-European map storytelling competition. Actually, the deadline was today, and within the next few days, the results will be published. So different schools across Europe, they tested the training courses for map storytelling. They developed their own story maps for different sustainable development goals, and we saw some pretty impressive results. So the fourth core module, map storytelling, and last but not least, coding and robotics. Many different activities, step-by-step guidelines on how schools and students may develop their own projects related to coding, robotics, but also sustainable development. By connecting sensors at different parts of their school to measure temperature, humidity, precipitation, etc., or noise maybe, and develop their own, let's say, projects. And the last cross-cutting sub-module, let's say it's about assessment. And it's a brief e-module that we are explaining to teachers on how they can take advantage of different assessment practices and rubrics tailored to sustainability competencies, actually, and partially the unified competence framework. So it's, like a story explaining and defining why to assess your students' progress and knowledge and skills, who is doing that and why is doing that, and how we can assess those competencies in the best possible way. And the last part of this presentation, it's like, a bombarding of different ideas, tools, and lesson, let's say, inspirations that we are using in all these courses and e-modules. And just see the pictures, the ideas, and the only thing we want is just to inspire the participants and, of course, most of the times teachers on how they can take advantage of geospatial concepts and tools. So we start with cartography and thematic mapping. The word here we see it's one online tool that teachers may use for primary school, let's say, activities. And this is the key fallacy between the Mercator projection and the size of the countries and the actual size of the countries while considering the Earth as a globe. And we see that as we're moving closer to the equator, the sizes of the countries based on the Mercator projection are closer to the actual size, but as we move into the poles, we see, these huge differences, let's say, for example, in Russia, in Greenland, in North America, etc., etc. So just one simple tool, one simple activity, fun activity for students. Other activities we are trying, to use different types of maps, of thematic maps, and let the students start reading or extracting information from those maps. Here is just an example from the US related to the education spending per student by school district. It's a choropleth or dosimetric map, actually, as it's called. And you see these visualizations, the colors, the different patterns. We have increase and decrease at the same time. So students are getting used to be extracting information from complex, let's say, or less complex thematic maps. Something more, let's say, funny, but still it's a map. Every shot that Kobe Bryant ever took, and this is a heat map of the shots that Kobe Bryant made and missed during his entire career. And we see the success rates and non-success rates, etc., etc. It's just an application. The students may play with this application, test different basketball players, etc., etc. 3D maps and tactile maps. We have the 3D printers, so it's quite easy for students to print, their own 3D maps in their school, or to collaborate with a community center and send their designs in order to be printed in the local community center and collaborate with the local community center, for example. Map storytelling. Just one example, refugee crisis. And here we see just a screenshot of a story map starting to describing how refugees started to move from North Africa, from Asia to the European countries. And we saw how students developed stories explaining those movements with maps, with videos, with audios, and it was pretty impressive. Those competitions that have been organized here in Greece, MAM competition number 1, the refugee paths, mapping refugee stories 100 years after 2022. The second year, mapping accessibility, can my schoolmate in a wheelchair come to a school? And last year, Spotin, our partner, organized a national competition here in Greece related to water routes and mapping the value of water, either metaphorically or let's say literally. Other activities related to GIS, how we can use different platforms and different criteria in order to identify areas and landing sites on the Moon and the Mars surface, and how students may work with multi-criteria decision-making. They can create their own 3D surfaces. More exemplary cases, they can create their own GPS. Here is an example from Athens. and it's an optimal route finding problem. It's quite easy to set it up in a GIS platform, and the students were pretty impressed. History and geospatial technologies, the ancient tunnel of Eupalinos in Samos, and we are trying to recreate the way that Eupalinos managed 2,500 years ago to drill from both sides of the mountain in order to create a tunnel, actually, and reduce the construction time in order to bring water to the ancient city of Samos. And he used geometry, actually. He used the topographic contours and the slopes of the mountain. Most people say that he used the Pythagorean theorem. The problem is that Pythagoras was born 500 years after Eupalinos, so still we don't have the answer, but we have GIS tools and activities for students where they can recreate this complex and still unsolved problem. Weather maps, like we mentioned here for Austria, and how the students can connect to different databases. They can download data from the Austrian meteorological network, and they can use some mathematical modeling schemes in order to create surfaces. Hands-on exercises, printed maps, and renewable energy sources. This is something we tested during the project in Greece, in Cyprus, in Portugal, offshore wind farms, and how primary school students and secondary school students can use printed maps and different criteria in order to identify optimal areas to place their wind turbines in the sea. Actually. So we have all these activities and the resources on the GEOBSERVE platform that Gustavo will present during the second part of the presentation. Many online GIS platforms tailor-made for teachers, most of them, like the Map Maker. We can easily visualize ready-made data that are uploaded on MapMaker. We can create different representations, our own maps, save those maps, and create reports or presentations. Copernicus browser, both for teachers and experts for satellite images, and there are many different ready-made exemplary cases for agricultural stuff, urban sustainability, disaster risk management, climate change, and many more. The EMODNet map viewer for those who are interested into the marine areas in Europe. Actually, it has been developed as part of a European initiative and project 10-15 years ago. So we can visualize seabed habitat maps, wind speed maps, different activities, human activities in the sea, and it's quite interesting. It can be used quite easily by teachers as well. More mapping platforms from the United Nations with different visualization, amazing ones related to different sustainability challenges. The Copernicus browser and Earth observation browser, some exemplary cases, urban expansion from space, and here we have an example from Dubai back in 2000 and 20 years later, how urban sprawl has changed just in 20 years in Dubai. Natural disasters, the Etna eruption from space, the students may identify different satellite images with a difference of 2 or 3 days and see Etna before and after the eruption, where we can see the lava flowing. The Aral Sea, one of the biggest, let's say, environmental problems during the past 40 years. And here we see some differences between 2019 and 2025. The water volume has been reduced again. Nature-based solutions and urban heat islands. We have activities on how we can take advantage of nature-based solutions and printed maps and digital visualizations in order to identify hotspots inside our city, our village, or town, and start developing different nature-based solutions solutions concepts in order to protect our city and area from heat waves or potential future floods. Coding, a couple of activities on how we can model, we can forecast the sea level rise using just 15 lines of Python coding. And here is an example here in the Aegean Sea. The students may play with different scenarios, 5 meters, 25 and 50. Okay, 25 and 50, it's a biblical disaster. That's impossible, but it's interesting students to see those differences. Earthquakes, we had the example from last year here in Greece, in Santorini, and with a few lines of code, we can download earthquake data, we can create visualizations, geometrical concepts, and how we estimate the epicenter using the trilitariation method. Robotics and light pollution, more activities. We also have a geo kit, an actual kit as part of the GEO-Academy project, and we have already distributed those geo kits in different schools across Europe in order to create and recreate activities related to light pollution, to monitoring different parameters using microbits, or create a seismometer, a seismograph. It was a lot of information, but we wanted, and I wanted to show you all these images and, of course, the methodological aspects of GEO-Academy. Some key takeaways. Yes, spatial, green, and digital skills matter, and they're interrelated, as we mentioned, and intertwined to the different topics of education for sustainable development. We should encourage teachers, schools, and of course, let's say, policymakers to integrate more geospatial tools and methodologies and more resources about geographic information systems and geospatial technologies to add one more geospatial dimension to the school formal and non-formal or informal activities. Of course, we still have 3 months until the project ends, so everyone may join the GEOBSERVE community. It's mainly for schools, and we will see our communities, but it's not only for schools, it's also for organizations, for individuals, for educators, for everyone who is willing to support, let's say, school activities or share ideas or events or training opportunities. And Gustavo is going to show now those numerous training and teaching resources we have developed and uploaded on the GEOBSERVE platform. And we all wish to you to become spatial thinkers. That's quite interesting. And yes, you will gain some superpowers. That was the presentation. Thank you very much for listening. Many different slides, but we tried to cover all important aspects of the GEO-Academy project. I don't know, Shana, if questions and discussions will be at the end of the webinar. Is that correct?
Yes. Mm-hmm.
Okay.
If anyone has a question now, we can also maybe stay on that part and take questions, but I don't see any raised hands or nothing in the chat. But if someone has a question, yeah.
Mm-hmm. Feel free to unmute yourself. You may turn on the camera and we may discuss about comments, ideas, challenges you may identify in this whole idea. Otherwise, we will be having a Q&A session at the end of the webinar. Okay, I think we can move on to the second presentation from Gustavo. Gustavo, are you ready?
Yes, I am ready.
Okay, perfect.
Okay, so thank you, Lucas, for the excellent presentation on the GEO-Academy project. Shall I just remind me how much time I have, if it's 1 hour this webinar or if it's...
It's 1 hour, so it's until 5, yeah.
Okay, okay, I'll be short to leave time for the questions at the end, some interaction. So I'm going to share my screen. By the way, I'm Gustavo Rojas. I'm from Núcleo in Portugal, and we are responsible for the work package 4, which is the community building work package of GEO-Academy. And in this regard, we are one of the main works that we developed in GEO-Academy was the GEOBSERVE portal. Do you see my screen now? Yes, okay.
Yes.
So if you go to the GEO-Academy main website, which is geoacademy.eu, there will be a button on the top right that takes you to the portal.geoacademy.eu, which is the GEOBSERVE platform. So this was developed by Núcleo with support from the partners. And the purpose of this portal is to congregate all the resources and tools that were created by the collaboration on the several topics that Lucas just presented. And on top of that, we also have the e-modules, which are the training modules that our consortium have prepared for the teachers, and also the communities where you can interact with the teachers. So all of this is available at portal.geoacademy.eu, and it is freely available. Everyone can join. What I'm going to show you is just a quick walkthrough through this platform, starting with the registration. So when you visit it for the first time, you see a login button here. That's where you can create your account, or if you already have an account, where you can log in. There are a few important details that I want to highlight. The first one is that you need to accept cookies. So you see probably a warning like this one to what you do want to do with the cookies. Sometimes people just reject them, but for the websites, for the portal to work properly, you need to accept the cookies, otherwise you have problems. So please select accepting all. And when first accessing, you have the option to log in, and this will show you a screen like this, where you can register. If you don't have an account, you need to register. So you choose a username and your personal data, that is all protected by the GDPR. And don't forget to check this button here, the CAPTCHA, to say that you are not a robot, is the top button, okay? On the bottom here is just an image that is reminding you to click on this box to confirm that you are a human. After you complete your registration, you will receive an email in your registered email just to confirm your registration, and then you can access the portal. So that's what I'm going to do. I already have an account, so I'm going to log in with my username and password and show you what the portal has. I'll start with the resources and tools. So if you go to resources and tools, you have the list of many websites and tools and applications that you can use in your classes or in your training to learn more about geotopics. You can filter by the age range, by the content type, by the duration, also by the language, and of course the geo concept that is related. So you have a list of more than 40 resources that were curated. You can visit each one of these resources here that will give you a brief description and a link to the full resource. So it's very useful if you want to look for a specific resource or tool that you can use to enhance your classes, or even to learn more about a specific subject. You do this in the resources and tools. In fact, this first section is open to all participants. You don't need an account to visit the resources and tools, so you can share it with everyone. But to see the other content, you need to create an account. When you create an account, you are automatically added to the international community in the GeoHubs. So the GeoHubs are the national hubs, in this case in the portal, that will make you more close to the other teachers in your country. So you have one GeoHub for each one of the countries in the consortium. So we have here Sweden, Portugal, Greece, Cyprus, France, Bulgaria, and Austria. So in each one of these national hubs, you can also join these hubs to interact with teachers in your own country or in your own language. You have to join these national hubs, and by default, you are added to the international GeoHub. So every participant, when register, will join this international GeoHub, and here you can see all the members. You can look for specific members. You can visit their profiles, and you can also have discussions with your fellow colleagues in the international hubs and also in the national hubs. You can share content, you can share best practices, meet new people, perhaps even starting collaborative projects in different European countries. So all of these you can access via the GeoHubs feature in the GeoBServe portal. You also have the option to visit forums, so you can visit the national forums or in the international forums, create topics, and have a discussion on specific topics that you want to know more about it. So this is another feature. There's the resources and tools, the GeoHubs, that are the communities and forums and groups, and we have the modules. That's why I'm going to spend a bit more time. So these are the training modules that were developed by the collaboration. We have over 40 modules on the different geo topics. So you can explore it in a different types, different approaches. If you go to the top level here, that is e-modules, you can select different modules according to the geotopic that is related to. So for instance, if you choose map storytelling, we will see all the topics that are related to the map storytelling geotopic.